Hello and welcome to the feedback video for assignment 3 Forces. In this video we're going to have a look at the last question on the assignment. At the end of the video you will be asked to complete a question that includes some similar concepts. Please pause the video, attempt the question and hand it in to your teacher as soon as possible. Okay, so in question 4 you are asked to calculate the tension in the cables of the crane lifting the capsule. And this question is really testing your knowledge of Newton's second law, or F equals ma. The trouble is that you have to deal with forces in 2 dimensions. Let's complete the vector diagram, sometimes called a free body diagram, where all forces are shown to act from the centre of mass of the object. I've highlighted in the diagram the 3 forces acting on the capsule: weight vertically down and both tensions up each cable. The question states that the capsule is still, it is not accelerating, and if that's true then the sum of all the forces acting on the capsule must equal 0. If we resolve in both the x and y plane, the forces should show to be balanced in both planes, and therefore show that there is no resultant force on the capsule and therefore no acceleration. This means if we resolve both tensions in the vertical or y plane, they should balance with the gravitational or weight force that is acting vertically downwards. And if we resolve both tension forces in the horizontal or x plane, they should add together to give a total force in the x plane of 0. Remember, as the horizontal component of T1 is to the left and the horizontal component of T2 is to the right, they should be equal in magnitude but opposite in direction. They will effectively cancel each other out. So if we add together the 2 tension vectors in the y plane, we get the upward resultant force of the 2 tensions. For 0 acceleration and 0 resultant force, this must be equal in magnitude but opposite in direction to the weight force. As both tension forces are acting at the same angle from the vertical, they must be equal in size. Their vertical components will be the same, and so the resultant force of the 2 tension forces is equal to 2 times the vertical component. With a little rearrangement, we get that the vertical component of each tension force is half the weight force, which we can calculate as we know both mass and gravity. In the vector diagram, you can see the 2 triangles produced. As we know one side of our triangle and one angle, we can apply some trigonometry to complete and solve this problem. Cos of 20 will equal the adjacent vector divided by the hypotenuse vector of the right angled triangle, where the adjacent vector equals weight divided by 2, or mg divided by 2, and the hypotenuse is equal to the tension force that we are trying to calculate. Now if we look back to our diagram, I can take the values for both mass and gravity. Here I'm taking is 9.8. As the direction is made clear in my diagram, I'm not going to take the acceleration of gravity as negative 9.8. I'm just interested in its magnitude. Here I have calculated half the weight force and rearranged the equation to get the tension force as the subject. You need now to ensure your calculator is in the correct mode in degrees and type in your values carefully, and you should get an answer of 6,257.37 newtons. As the mass given is to 4 significant figures, you could also give your answer as 6,257 newtons. Okay, if you could pause the video, complete the question and hand it back to your teacher as soon as possible.